Hi and Assalamualaikum. My name is Azril Fidawi Azmi. Okay. For the objective of this experiment is to investigate the relationship between angular rotation and the tangential movement of the shaft. Also to show that V equals to RW.
The apparatus that we use in this experiment is wheel and axle apparatus, a weight hanger, marker pen, and lastly measuring tape.
Next procedure. At the three type of dimension. Like this, okay. Like this, there's 1, 2, and 3. Okay, and then put the weight. Consider this as a weight. And then this and this, and then we hang it at the wall.
By marking the reference point at the end of the shaft that located at the pin side, the reference point will be used in recording the number of turn of the shaft.
These are the dimensions for every shaft and distance travel for hanger. From the table distance travel, we need to plot a graph distance travel versus number of revolution for every hanger. These are the graph for hanger 1. This is for hanger 2. And lastly is for hanger 3.
Question first. Compare and discuss the result from different types of shafts. There is not too much difference in the dimension between all three shafts. This makes the average dimension for all shafts differ in just about 0.05 to 0.32. Second, give your comment or suggest at least 4 cause of errors that may affect the result of the experiment. For the experiment result, there is a different value because of few factors, which is air resistance that cause the wake to spin or pull, then gravity that make the value of the experiment become too large. Next, machine inaccuracy that cause an error in reading and thermal expansion, which makes the wake to be too big to be tested. Third, explain how the theories in this experiment give effects in some real-life applications together with example. The theories can help people in real life, which is someone who working as lift technician. They can calculate how much angular velocity is needed for the gear to turn and pull up the lift to carry passenger by using formula and some theories that they have learned.
For the discussion of this experiment, for the first question is compare and discuss the result from different type of shaft. For my answer, the result for shaft 1, shaft 2 and shaft 3 have a different value. This is because the parameter for each shaft are different, and even they use the same length of the string, they will get a different initial height. For the second question, give your comment or suggest at least 4 cause of errors that may affect the result of the experiment. My answer is 4 cause of errors that may affected the result is parallax error, inaccuracy of an apparatus, environment and thermal expansion. To overcome parallax error, you must record the data 3 times and take the average of the data. For the third question, explain how the theories in this experiment give effects in some real-life applications together with examples. My answer is the theories in this experiment give effect because, as we know, acceleration is occurred by derivative of the velocity, which means the more movement of the wheel and axle, the greater the acceleration will occur. The example of wheel and axle such as gears, the vascular chains and crank, and the last is Ferris wheel.
For the discussion, first compare and discuss the result from different type of shaft. From the result, we can see that shaft 1 has a smaller average diameter other than shaft 2 and 3, while shaft 2 is smaller than shaft 3 but bigger than shaft 1. Lastly, shaft 3 have a biggest average diameter than the other two shafts. For the first revolution, hanger 1 has the smallest distance travel other than hanger 2 and 3, while hanger 3 has the biggest value for distance travel. Okay, for the second discussion, give your comment or suggest at least 4 causes of error that may affect the result of the experiment. First is instrumental. For example, is when the rotation of the wheel and axle does not rotate in the same rotation. Error for the environment is when the environment affect the way hanger is swing when we experiment. Observational is, for example, is when parallel in reading a meter scale for the hanger height and distance. Theoretical is when the theory said that the surrounding temperature will not affect the apparatus but affect it. For the last discussion, explain how the theories in this experiment give effect in some real life application together with example. So for velocity, the application is moving train. The train start from the rest and keep moving forward because of the velocity. Second theory is acceleration. For example, like swing. The velocity of the swing will increase and there will be an acceleration after velocity is increased. I think angular velocity, the tire of a moving car. The faster the tire spin, the faster the car move. It means that if the velocity is large, angular velocity also large because v is equal to r omega. For angular acceleration, the application is aircon fan. The angular acceleration will increase as time passes, and when the angular velocity is increased, the radius is also larger.
Alright, for discussion 1, we need to compare and discuss the result from different types of shaft. Okay, there are 3 shafts in this experiment, and the reading measurement of circumference was taken 3 times for each size of shaft, and we need to calculate the average values. For shaft 1, it has the smallest size, so it has the smallest value of average diameter, then followed by shaft 2, and the largest shaft is shaft 3, because it has the largest value of average diameter. It can be said that when a shaft has a large diameter, so the average diameter also will be large. For discussion 2, my comment or suggestion for errors that may be affect in this experiment is first, systematic error. The effect is this error happens when using a poorly calibrated instrument to measure the diameter of the shaft. Second, parallax error. This error that occurs when the pointer on the steel while measure the height of the hanger is not observed along a normal line to the scale. Third, rounding off. It is a mathematical miscalculation that caused by altering the number to an integer or on with fewer decimals. Last is error in procedure. Approve the accuracy in measurement by knowing the tools that will be used in the experiment and apply a correct technique. The last discussion is I will explain on how the theories in this experiment give effects in some real-life application. So the first theory is velocity. The application is a moving car. Velocity that measures motion starting at rest and moving to another place with respect to time. Second is acceleration, dropping down an object. The velocity of the object increasing as it falls down and have positive acceleration, which is downward. Third, angular velocity, a ceiling fan. The rate of velocity when a fan is rotating around a specific point. The last theory is angular acceleration. The example is a Ferris wheel. The Ferris wheel starts rotating and slowly speeds up its rotation.
In conclusion, I have achieved the objective in this experiment. First, find the relationship between angular rotation and the tangential movement of the shaft, and hence to confirm that V equal to R. From this experiment also, I can learn that this theory can be used in our real life. So this application is very important for people who use in their work, such as lift technician.
For the conclusion, the objective were achieved during the experiment. At the end of the experiment, we will study about the various type of shaft is affect the result of the experiment. Other than that, we get to know that angular rotation and the tangential movement are related to each other, where the more angular rotation, the greater the tangential movement occur.
For the conclusion, from the result, we see that we achieve the objective of this experiment. We get to find the relationship between the angular rotation and the tangential movement of the shaft, and we get to confirm that V equal to R times omega. Omega is the angular of velocity. First, measure the dimension for every shaft 3 times to know the average. diameter for every shaft, and then we need to measure the distance traveled for each hanger for every rotation. First, we need to measure the initial height and final height to get to know how much total distance for each hanger already traveled. Through that, we can confirm that V equal to R omega.
My conclusion for this experiment is it can be said that the objective was successfully achieved when we can obtain the V equal to R omega. Based on the results, the shaft dimension was measured by 3 readings that was taken by each shaft, and we need to calculate the average diameter. And for distance travelled, there are 3 hangers and we need to measure its initial height and the final height. After that, we can get distance travelled by using the formula h final minus h initial. Then we need to plot a graph based on the data and calculate the angular velocity. In every experiment, we know that there must be some errors, but for this experiment, the cause of errors that may be affect is like systematic error, parallax error, rounding off, and error in procedure. Besides, we need to know about the application and give some example which is suitable for this experiment to show the difference between velocity, acceleration, angular velocity, and angular acceleration.